Here, this one we read 0. The first one, 0. So here, basically, the degree will be 3. So we are calculating the first one. So when we go to the second one, when we go to the second one, now J will read 1. So the degree will be 2, as it is here. When you go to the next one, which is here is 2, the degree here will read 1, which is this and that. So after it's done with this, now with the -5, it's going to start now -4. You don't need to do the same. So it's basically going to do that. So then for that, let's bracket that. Then when you get this value for that, you are going now you get the first one, you are going to add it to sum. So when you get the second, because now the product of this term is going to be stored in sum. So in the next row, we are going to add now the previous product. We are going to add it with the next product like that. So and again after that, we need to add this the last one, the last value in the coefficients. So we're going to add that after we exit the loop. So we exit the loop, get the fx is equals to not the outside of this, but outside of the first loop there. fx is equals to fx sum plus self dot coefficient. Now we are taking the last value. To get the last value from a list, we use -1 like that. So after we calculate the sum of the values with the x values from here up to here, then we are going to get the last value to add it to the sum of these ones, so that we get the complete value of the fx value. So like that. Then we are going after that, after now the sum, we calculate the sum of the polynomial function, we are going to add it into the fx values list. So fx values dot append, I'm going to append the fx sum like that. So and that's how we calculate it. So the next step we are going to do is now plotting. We are going to plot the curve. So we are supposed to import the matplotlib. So from matplotlib import pyplot as plt. So that one will help us on the drawing the curve. I mean with the requirements to draw the curve. So let's read these ones. So plot, let's now do the plotting. So let's plotting graph like that. So plot dot now we are going to define the axv line dot axv line. So 0. So axv line will be black. So we are drawing the lines for the graph. So let's draw the lines. So we are doing the vertical lines. So let's draw the horizontal lines. So let's draw that. So color, it's supposed to be color. Color. So let's draw the horizontal now. Yeah, like that. The x label. The x label. The x will represent the fx values, or yeah, or the rate values. No, the rate values, which is the domain values. Let's call them domain values. So domain values. So y will represent the y label. Represent the y is going to represent the fx now. The fx values. that. The other thing we need is now after now we represent that, we need to plot the graph, the grid. The other thing now we need is now this works of our values, plotting now the values. So we are using the domain values to plot. That will be the x values, and the other thing we are going to do now is the fx values for y. Fx values, like fx values, yeah, like that. Then and after that we can show now the curve. Fx dot show plot dot show that, yeah, like that. So now we are good to go. So that is it for plotting. But now when we are plotting it, show we are supposed to show something like the domain used on the polynomial. Let's print that here to show some more details on what's the curve, the values that were used on the curve. So you're going to print the domains used, domain domains used. So we are going to access the array. So we are getting the self dot domain. You can just return it as a list, or as the values. So the domains used, let return the list. Other thing you are going to return is the polynomial function. Polynomial function is, so then we pass the polynomial function itself. So we are going to call the self dot poly function that print a new line. That think we can test our program whether it's working correctly. I think we didn't omit anything in the graph plotting. I think everything is okay. So you can maybe print here the top of the, does it? I think it should have a title, plot dot title. I think it's written like that. Domain values, was fx values. No, it's fx values against domain values. Values. Fx was domain values. Like that. So let's see. So let's confirm first, either we code the functions correctly, plot poly and set domain. Plot poly and set domain that. Yeah. Let's run our program and see whether it's working nicely. So let's first quit on this. So let's clear that. So run again. You have a problem with the indentation in line 79. Problem with the indentation in line 79. This value here. Let's run again. So again, the protein, I think we never did that before we even run this. It's something I remember. On if the values of domain, there's something I said when we were starting the video. If these all values are not set, we are not supposed to plot the graph. So that value, that thing is supposed to be set here. So let's do that. For if self dot degree is less than or equal to 0, like that. If that value is less than or equal to 0, it means that the degree is not set. Again, if domain list is empty, that means again the domains are not set. And if the coefficients list is empty, that means also the coefficients are not set. And with that we can't do the plotting. So we have to set that first. So that's what we are going to do before we run our program again. So let's do that. So if self dot degree is less than or equal to 0, and self dot coefficients, self dot coefficient is equal to empty, so it's supposed to be and if any of this is empty, you're not supposed to do the graphing, and self dot coefficients. The other one is domain equals to empty. So if they are empty, if self dot degree is less than or equal to 0, if self dot coefficient equals empty, and if that equals to true, that means we cannot do the graphing. So we are going to tell the user, please provide preset all the requirements, preset all the values for degree, coefficient and domain. Yeah, like that. In the next line. So else now if they are now we can do the protein. Yeah, like that. So let's now test our program. Let's clear first. Yeah, let's try with the plot the polynomial. You can see preset all the values for degree, coefficient and domain. It can't do the protein. So the other thing is you have to test the coefficient, because you can't provide the coefficients when you didn't just first set the degree. You have to set the degree first, then you can set the coefficient. So let's try the one for coefficients. You can see, please input the degree value first. So you are supposed to start from the first to the for the option so that it works correctly. So let's start the first one. Input the degree value 3. Set the degree. The degree was set. The other one is set the coefficient. Enter the coefficient of degree 3, 9. You can enter 3. This can be 1. And the other one can be 8. So you have the polynomial function is the coefficient list. Then the other thing we are going to do is to set the domain. Set the start. Can give it -5. Give it 5. Step value 1. So domain value. So now we can do the protein. You see, when you are doing the protein, enter option, we give this the polynomial function. It gives us the domains used and the polynomial function that was used, and this is it. So again, as you can see here, we didn't include the 5. This is because of the NPLH. When you give the start and stop, the stop value isn't considered. So let's go back there and edit this. So this is the start, this is the stop. So the value 5 that is not considered, it starts from -5 to value 4. So we are supposed to add that plus 1 so that it can consider -5. So this value will lead us, if we entered 5, this will lead 6, so that our 5 will be included. So let's test that again. Fine. Let's start a new one. So set degree, setting the degree as a 3 again. Set the coefficient. You can use 5, 6, 3, 8. So like that. Set the domain. We're going to repeat that, -5, 5, and 1. So let's do the plotting. You can see now it includes the value 5 in our domain value. So basically that's how we do it. Again, there is something you might not realize from this. Let me show you. Because now we have not exited the program. Suppose we want to change the value of coefficients. Let's take that. You see, it gives us the coefficient. So we want to change the value. So let's try to change it and see. So instead of the coefficient we had set here, 5638, let's see what happens. 7, 5, 8, 1. You see, these values from the previous one, it just added the more values to the coefficient list. So when you are going to run this, it's just going to take the values that were previously used because it didn't clear the list. So what you are going to do, every time you have to set the value for coefficients of the domain because they are both are the list, you're supposed to clear the list first before you go ahead to set the values. So if there is values when you are setting the coefficient, if there is some values in the list, they are going to be cleared. So basically, let's do that. That's just simple. When you are setting the domain, you're supposed first to clear the domain. Dot clear like that. The other one is we are supposed to clear the coefficient. Self dot coefficient clear. Yeah, like that. So the other one is now the poly function because you realize even the poly function when you are doing this the here your setting is using the poly function. If you are to set the coefficient now again it's going to add to this. Let's see. Now after the set the coefficient, you see how it does now again with the poly function. So again we are supposed to edit on that. So here self dot poly function. So you give it an empty string like that. So let's now run the program. So quit. Let's clear that. And again. So set the degree. Give it 3. Set the coefficient. So input. I'm gonna give it 5, 4, 7, and 1. Yeah, like that. Let's set the domain. 5. You can give any value you want. I'm just using this for demonstration. So let's plot that. Yeah, you can see it's working nicely. So let's now try to, the degree has no problem. So because it's just a value. So let's try to set the coefficient. Now we are now trying with the new coefficients. We see like it behave how it behaved previously. We see whether it will clear this list and now add the new values we are entering. So you see this is the value for the previous list now of the coefficients. So let's see, let's try this one. 9, 6, 3, 7. You see how it does. Now it cleared the previous one and now it sets now with the new values we enter. So that is it. Now for the domain, let's try a new domain. C3 to 9. Step is on. You see, it gives us different values 3, 9, 1. So it's not adding them to the previous one. So let's try now to print. You can see now the graph is different. Domain used 391. You can see, yeah, that's basically all for polynomial function. So I think the series was amazing. So if you have any question on that, maybe you can ask on the comment section. But that is it for polynomial functions. You can go ahead and do some more modification. Just that was on how I hope on doing the series you understand more on lists and classes. So basically that's how we do it. And there's more ways you can do that. Not just this just the way. Again, when you are doing the coding, please ensure that you comment on your code. Give it some headings to explain your code. I didn't do that, but definitely ensure your code is commented well. And really documented well on, like this, plotting the graph. So if someone comes to your code, he can be able to understand. But that's all for the series. I hope you enjoyed, and thank you guys.